Right, 6-2 is solving quadratics using square roots. So now we've gotten pretty good at radicals, pretty good at square roots, and we're going to utilize those to help solve our quadratic functions. This is a section that it is okay for you to have a calculator. Sometimes I'm going to ask you to give me answers in decimal form. Sometimes I'm going to ask them for simplest radical form. So depending on which one I ask for, you may or may not need your calculator. Okay, so remember to, when you solve any kind of equation, we're always undoing something, right? Undo each function to solve. That's what we always do, right? We always work backwards. So we know that if we need to undo addition, then we subtract. If we need to undo multiplication, we divide, and vice versa. Well, how do I undo? We've been working on exponents, right? How do I undo squaring something? Well, the way I undo that is I take the square root of that. Okay, so that's a main idea of what we're going to work with in this section. So you always want to solve for x, right? You always want x by itself, so you need to undo whatever's been done to it. This x has been squared, so in order to solve that, we need to take the square root of both sides. Now remember that every square root has two answers. One positive and one negative. Okay. So let's take a really easy one. The square root of 4 is 2, or it's negative 2, because 2 times 2 equals 4, but negative 2 times negative 2 always equals 4 also. Okay, so you just need to remember that. You've got one positive and one negative answer. That's important in this section. Okay, so here's a nice and easy one. We have square root of x squared is just x. It does that. And then the square root of 25 is 5, or negative 5. And typically the way you're going to write that is you're going to write x equals plus or minus 5. Some of you have seen that symbol and you weren't quite sure what it meant. That's exactly what it means. It means plus positive 5 or negative 5. All right, let's try this. 3x squared equals 33. Remember, you can't take the square root of that unless this is a perfect square. This coefficient out in the front is a perfect square. Then you can take the square root of both sides, but it's not. So it's much easier to make sure this x squared is by itself first before you attempt to solve it. So it's kind of like a reverse GEMDAS. So I'm going to divide both sides by 3, and I'll get x squared equals 11. And then I need to take the square root of both sides. And here's where you can use your calculator. So because this is asking in decimal form, I can go ahead and do square root of 11, which gives me plus or minus 3 point, and you can round it to the nearest hundredths, that's fine. So in this case be 3.32. And think about what that means. That's about right, because 3 squared would give us 9, and 4 squared would give us 16, and 11 is somewhere in between 9 and 16, but closer to 9, so it's on the lower end of the 3's in there. So that would be your answer for that. Okay. So I want you to think about that reverse GEMDAS as we work on the third example here. So we need to solve the equation exactly like we normally do. If that was just 2x squared, or excuse me, 2x minus 5 equals 10, you guys would have no problem with that, right? You'd add 5 to the other side and then you divide by 2. So this is the same. The only difference is now we have one more step in taking that square root. So we're going to add 5 to both sides. We would get 2x squared equals 15. Then we're going to divide by 2. Since we're in decimal form, we can go ahead and make that 7.5. That'll be fine. Take the square root of both sides. So we would have 7.5 square root, which gives us plus or minus 2.74. If you're ever not sure about this answer that you have, work your way backwards. So now if I squared it to get this answer, let's do 2.74 squared. And we get 7.5076, which is pretty close to 7.5. That's a rounding issue, but essentially the same answer. Okay, good. All right, the next three we're actually going to leave in radical form. Radical form is actually the most accurate way to leave your answers because it doesn't involve any rounding, it doesn't involve any guesstimating of an answer. It's an actually truly accurate answer. So it will depend on what we ask you for as to what form we would like that in. All right, so we need to get that x isolated. So the first thing I'm going to do is add 3 to both sides. And I'll get 80 equals 2x squared. Then we'll divide by 2. So we get 40 equals x squared. Now since I'm leaving it in a radical form, I need to break this down into perfect squares and whatever's left over. So first thing I need to do is figure out what I can multiply together to get 40. And I need to use my perfect squares. So if you need to write your perfect squares down again, just to help you with that, that would probably be a good idea. The first 10, I would say, are the most used. But it's always helpful if you recognize them because then you can think about what comes out of a number. Let's see, 36, 49, 64, 81, and 100. Oh, let's keep going. Why not? 121, 144, 169, 196, and 225. So there's your perfect squares 1 through 15. 1 squared, 2 squared, 3 squared, and so on and so on. So now let's go back to our 40. And what is a number that could come out of 40 that's on our perfect square list? Well, 40 is 4 times 10, so that's the square root of 4 and the square root of 10. 10 is not a perfect square. It doesn't have any perfect squares that you can take out of it. So now that 4 is going to simplify to 2 square roots of 10 equals x, and we're going to do plus or minus. So if you want to turn that around because you're used to seeing the x on the left-hand side, that's fine, 2 square roots of 10. Remember how you can always check this back. Since this is a square root, it's like there's a 2 in here. So you do 2 times 2, which is 4, times 10, which is 40, which is what you were taking the square root of. So that's radical form. We're just going to leave it just like that. Okay, let's try 25 equals x squared over 3. So we're going to multiply both sides by 3. So we get 75 equals x squared. Then we're going to take the square root of both sides. Well, it helps because 25 is a perfect square. So I'm going to flip this around. So we have x equals square root of 75 can break into 25 and 3. And then square root of 25 is 5. Square root of 3 is not a perfect square, so we leave it alone, just like that. Okay, 5 squared is 25 times 3 is 75, so that checks out. Good. I want you to go ahead and do the third example here in this section on your own, and then come back and check your work. So I'm going to add 5 to both sides. I'll get 4x squared equals 16. Divide both sides by 4. I get x squared equals 4. Now I'm down to the point where I can take my square root. So x equals, nice that that's a perfect square, makes life easy. So square root of that would be plus or minus 2. Good. All right, so let's do a couple more, and I think you're good to go in this section. It's a pretty easy section, actually. So on the bottom here, we need to subtract 8 from both sides. X squared equals negative 5. Ooh, now we run into a problem. So I want you to think about how you would get negative 5. Just think of two numbers that you can multiply together to get negative 5. You could either do 5 and negative 1, or negative 5 and positive 1. So the problem is you can't take a square root of a negative number because you don't have signs that could ever match in order to get a negative. So we call that, for now, we're going to call it a no solution. When you get into Algebra 2, in Algebra 2, you will learn something called complex or imaginary numbers. And that actually allows you to take the square root of a negative. It's actually really easy. Sounds much more complicated than it is in imaginary numbers. But we're not going to worry about that right now. So if you get to this point and you try to take the square root of both sides, you cannot take the square root of a negative number. So for now, we're going to say that's a no solution. Okay. So for now, that's going to look like that. And it's going to be a no solution. In Algebra 2, that'll change, but not now. That gives you something to look forward to. It's actually fantastically easy. All right, let's do one more example, and then we'll be done with that section. Isn't that quick? So 4 minus 2x squared equals negative 1,660. Okay, so move this around. So that's positive 4, so I need to subtract 4 from both sides. And I'm going to get negative 2x squared minus 16 equals negative 1664. And I'm going to divide the negative 2 out from both sides. And so that should give me 832. And now I'm going to figure out what factors out of that. So I know 4 will come out of here. So let's see what I could do there. So that would be square root of 4. 4 goes into 800 200 times. And then into that another 8. So that would be 208. Let me just double check that. 832 divided by 4 is 208. Well, 4 also goes in here. So let's divide that by another 4. So I get square root of 4. Square root of 4 is 52. Well, 52 is also going to break down into 4 and 13. So I could have tried to take, if I had seen this, 8 comes out of 832 104 times, and I would have only had to take 4 out one more time. But that's okay. So each one of these is going to reduce to a 2. And so we should have 8 square roots of 13. So let's double check that and make sure that that's right. So 8 squared would be 64 times 13 gives us 832. So we're okay. If you wanted to do that in decimal form, you could certainly do that. So 832 and the square root of that would be 28.84. I would really prefer that it's left in radical form, but it depends on the way the question is asked of you. Okay. This is my preference to be left that way. Gives you good practice with simplifying your radicals also. So that's 6-2. There you go. Thanks.